in comparison to its predecessor, legacy Grub. When a computer is powered on, it first assembles CMOS settings in its BIOS and initiates a power on self-test, or post. After reading these settings and performing the post, control is then transferred to the master boot record, or MBR. Once control passes to the MBR, it will either load a bootloader installed within its storage space or initialize a bootloader on a separate partition it points to that has been marked as active. Control then passes to the bootloader, in this case Grub 2. If there is only one operating system on the computer, it initializes, reads its configuration files, and begins to load the Linux kernel automatically. If there is more than one operating system, Grub 2 will present a menu to the user and allow them to choose the operating system they wish to boot into. The default operating system and timeout values can be changed within the Grub 2 configuration files. Once the Linux kernel loads, Grub 2 is no longer active, and the kernel then initializes the system by loading daemons into memory. The first of these daemons is the init daemon. It loads all the other daemons necessary to bring the system up to a usable and productive state. To summarize Grub 2's changes and improvements over the original legacy Grub: 1. A new configuration file structure. 2. Scripting support. 3. Dynamic module loading. 4. Rescue mode. 5. Themes. 6. Graphical boot menu with splash capability. 7. The ability to boot ISO images directly from the hard drive. 8. Non-x86 platform support. 9. Universal support for UUIDs. 10. Internationalization and non-ASCII character support.
For this triple boot setup, we partitioned a 500 GB hard drive and a laptop with an MBR partition table. The first partition was formatted as a Mac journaled file system. The second partition was a Windows 7 system. The third was a Windows 7 NTFS OS partition. Finally, we made the last partition extended and created 3 logical DOS drives. One was ext4 Linux for Ubuntu, 2 was a Linux swap partition, and 3 was an NTFS data partition. The operating systems were installed in the following order. First, Snow Leopard. Second, Windows 7. Third, Ubuntu 10.10. Today we're looking at the Grub 2 bootloader, and we want to see how it works with multiple operating systems. So in this case, I've configured a triple boot on an inexpensive laptop. It's a Toshiba Satellite. It's about a $500 laptop, i3 processor, 4 gigs of RAM. So not that sophisticated. And the 3 operating systems we have installed on it are, on the very first partition is Snow Leopard. Okay, and not really a Macintosh here, it's a PC, so it's sort of a Hackintosh. But that's the first partition. And then the next 2 partitions are Windows 7, a system partition, about 100 megabytes, and an NTFS partition for the operating system. And then the last 2 partitions set up are an ext4 partition for Ubuntu 10.10 Maverick Meerkat and the swap partition that Linux needs. So let's take a look at how Grub 2 works with the boot menu and multiple operating systems, and we'll just boot into each one real quick and test them out. So I'm going to go into Ubuntu. Okay, this is just Maverick Meerkat. Okay, and the next one we want to test is Windows 7. And now we've logged into Windows 7. And finally, let's try Snow Leopard on our Hackintosh. And now we're booting into Snow Leopard, our OS 10.6, the world's most advanced operating system. Ta-da! This is our third operating system. In addition, there's also a data partition. Some of these are logical DOS drives on an extended partition. So 3 operating systems and a data partition. And this is Snow Leopard, and every standard fare, Safari, obligatory Owl City, FLV or video. Well, instead I get advertising. So instead I'll do the Human League here. Obligatory Human League video. Anyway, standard fare.
Let's take a look at the Grub 2 bootloader's configuration files.
Okay, let's open up the terminal and we'll look at some of the Grub 2 configuration files. And things have changed considerably since Grub 1, or what many people call Legacy Grub. The files are not the same names, the files are not in the same place, the structure is very different from Legacy Grub. So even if you're used to the first version of Grub, you may find this one very different.
Boot Grub contains some of the main configuration files.
And I'm going to go into boot, and I'm going to go into a subdirectory called Grub. I'm just going to list some of the files here, but in the Legacy Grub, you used to have a menu.list file, and that menu.list file is no longer here. Okay, it's been moved.
Boot Grub CFG is the main configuration file, but it should not be edited manually. Instead, you will edit configuration files in the etc folder and use the command update grub to compile changes to boot Grub CFG.
What you have instead, I'll cat it, is a grub.cfg file. Okay, and although you could edit this in a text editor, you're not supposed to. The idea behind Grub 2 is that you should never edit this file directly. I'm not saying you couldn't, I'm just saying you shouldn't. Instead, what you want to do, let me recurse up here and go back.
etc default grub is one of the main files you will actually edit.
And then in the etc default directory, if I go to cd etc default, in this directory there's a file that I want to edit, and it's just called grub. And that's sort of the default, or one of the main configuration files. And what happens is you'll edit these other files, and then when you do it, you'll use the command update grub, and it pretty much just calls makefile. And it will take all of this information and compile it into the grub.cfg file in the boot grub folder. But the way that it's intended that you modify boot menu entries under Grub 2 is that you modify